This problem is an extension to the original one where you just need to determine if a loop is present in a single linked list. This time, you actually need to return the node where this loop is beginning. So, if you're hearing about this word loop in a linked list for the first time, I would recommend you to check out the original problem first. You can check the link in the description below. Hello friends, welcome back to my channel, a place where we explore the life of technology and make programming fun and easy to learn. Today, we would be solving the problem linked list cycle 2 on LeetCode. First, I will explain you the problem statement and we will look at a sample test case. Next, we will try to come up with a brute force solution and see why that is not an efficient one. Going forward, I will show you an efficient solution to the problem followed by a mathematical proof to exactly tell you why this works. After all of this, we will be also doing a dry run of the code so that all of this sticks in your mind and you never forget about it. So, without further ado, let's get started. Okay, so let us first just try to make sure that we are understanding the problem statement correctly. You are given a single linked list with a head and you need to determine the starting point of the loop. Just a quick recap, what does a loop mean? If you look at this linked list closely, you can see that the next of this node points to an internal node in the linked list. So if you try to traverse this list and you keep on doing a next, what will happen is you will be stuck in this loop. Every time you do a next, you will be just be encountering all of the nodes once again. So this is a loop, right? In this question, what you need to do is you need to return this node. That is the starting point of the loop. So you need to return this node as the answer. Now, if this problem statement is clear to you, feel free to try it out on your own. Otherwise, let us look at some solutions that I can offer you. A good developer will always try to come up with a brute force solution first. That is because it can guarantee you if a solution to a problem exists. So if you're given this sample linked list and I ask you, okay, where does the loop starts? What is the first thing that comes to your mind? If you can somehow find the node which is repeating again and the first node that repeats again, that should be the starting point of the loop, right? So think about this. If you're traversing this list like this, and then once you enter this loop, the first node that you encounter that is repeated, this is your starting point of the loop, right? So this gives you some idea. Let's do one thing. Let me just write down all of the memory addresses of the nodes of this linked list. Remember that these are some random memory addresses, but they are guaranteed to be unique, right? Okay, I know these memory addresses now. What can you do next? You can start to traverse this linked list. And what you can do is you can create a hash set that will store all of the unique addresses. So let's say I start traversing this list. I am at my first node and this is the address A. So I add this node to my hash set. Next, I move to my next node and this is B. I check in my hash set if this node exists. It's not, right? So I will add this address also to my hash set. Similarly, what I'm going to do is I will traverse each of these nodes C, D, E, and then all the way up till node number J. None of these nodes exist in your hash set, right? So what will eventually happen is all of these memory addresses will be present in your hash set, correct? Now your pointer is pointing at node number J, right? What happens if you do a node.next now? As soon as you do a node.next, you will land at node number D, right? Now the memory address of this node is D. You will try to check if this address is present in my hash set. And you can see that the address D already exists. So what does that mean? This simply means that node D is your starting point of the loop, correct? So you can simply return node D as your answer. And this approach works. It is very valid. It will work for every test case. But do you see the problem with this approach? The only problem is that you are taking extra amount of space just to store all of the addresses. Think like this: if your linked list is very huge, then you need an additional space to store all of your addresses. And hence, this is not a space efficient solution. Can we do something about it? Let us have a look at it.
Finding an efficient solution to this problem is both easy and tricky. Let me show you the easy part first. Do you remember the Floyd-Warshall algorithm or the hare and tortoise algorithm? What did we used to do? We had a fast pointer and we had a slow pointer. Now, the main property was that the fast pointer was moving at a 2x speed than the slow pointer. That means that when the slow pointer would only move one place, the fast pointer would have moved two places, right? And in our cycle detection algorithm, what did we used to do? We kept on advancing these pointers in the same way until and unless they met, right? So you can see that the slow pointer is moving one step at a time and the fast pointer is moving two steps at a time. What happens when we continue to do this? We will detect the loop, right? So what will happen is the fast pointer will move two places, the slow will move one. Once again, fast moves two places, slow will be slow. Fast again moves two places, and the slow pointer moves one place. The fast pointer moves two places, and the slow pointer moves one place. Once again, the fast pointer moves two places, and the slow pointer also reaches the fast pointer. Now, this point is very crucial. You know that since they both have met, that means that a loop exists. You are sure about that, right? Now, the next part of this question is how do you determine the starting of the loop? To do that, the trick is that as soon as these two pointers meet, what you do is you take the fast pointer and you move it back to the head position. And this time, what you do is you move both the slow and fast pointers at the same speed. So, when I would do that, what will happen? Fast pointer moves one step and the slow pointer will move one step. Fast pointer moves one step and the slow pointer will move one step. Once again, the fast pointer will move one step and the slow pointer will also move one step. So you see, they both have met again. And this time when they meet, they will always meet at the starting point of the loop. And this is very crucial. This is your answer. So basically, to find an efficient solution, what you need to do is just start two pointers, a slow and a fast one, and when they meet, move the fast pointer back to the head and start to advance both the pointers at the same speed. It is guaranteed that when they both meet, they will meet at the beginning of the loop. Writing the code for this is very trivial and we will do a dry run in just a moment. But let us first try to see a mathematical proof and why this solution is actually working.
Okay, so it is very natural to think that how is this solution even working? How can you guarantee that when you move the fast pointer back to the head and then advance both the pointers at the same speed, they will definitely meet at the starting point of the loop? So let us try to prove that mathematically. Let us take up a very generic example. If you look at this example, I have a starting distance and then I have a loop, right? This is how your linked list looked, right? And this is the path on which the slow and fast pointers are moving, correct? So let us do some nomenclature first. Let us say the starting distance is x before the loop actually begins. And you know that both the slow pointer and fast pointer will meet somewhere in this loop, right? So let us say they meet at this point. What I'm going to do is I'm going to label this distance as y and I will assume L as the length of the complete cycle. So what does that mean? It means that this remaining distance, this would be L minus y, correct? Now, you know that when the fast pointer is moving, what will it do? It will traverse this path x and then it is possible that it will keep on running in this loop until it ultimately meets the slow pointer at this point, right? So let us assume that it makes n2 number of rotations inside the loop, right? So let us say n2 is the number of rounds taken by the fast pointer. Now, when the slow pointer moves, it will also travel this distance x and it will start rotating inside this loop, right? Before ultimately meeting the fast pointer at this point, correct? So let us assume that n1 is the total number of rotations made by the slow pointer. So you have two values now, n2 and n1. Based upon this, you can calculate the total distances traveled by the slow pointer and the fast pointer before actually meeting in the loop. So before meeting in the loop, the total distance traveled by the slow pointer would be x plus n1 times L plus y. That means x plus n1 into the length of this loop plus this distance y, correct? So this will give you the total distance traveled by the slow pointer. Similarly, you can calculate the total distance traveled by the fast pointer also, right? The fast pointer will move a distance x and then it will cover n2 number of loops before ultimately meeting at the point where both of them meet. So what will the total distance? X plus number of rotations and then the distance y. So now you know both of their distances, correct? You know some more facts, right? You know that the speed of fast pointer is twice the speed of slow pointer, right? That easily means that the total distance traveled by the fast pointer would be twice the distance of slow pointer, correct? Once you have all of this information available, what you can do is you can start plugging in these values. So I will take this distance traveled by the slow pointer and I will plug it in over here. And I will take this distance traveled by the fast pointer and I will plug it in over here. When I plug in both of these values, I get an equation. Okay, time to put your mathematical hats on. Let us try to solve it. What we can say is x plus y plus n2 multiplied by L equals to 2x plus 2y plus 2 times n1 into L, right? That would simply means n2 minus 2n1 multiplied by L equals to x plus y. Or we can simply say that x equals to n2 minus 2n1 multiplied by L minus y. Now focus on this equation for a minute. Let us look at this value, n2 minus 2n1. What are n2 and n1? n2 is the number of rotations by the fast pointer and n1 is the number of rotations by the slow pointer, right? So when you will equate this equation will give you some positive number, right? It could be 1, it could be 2, it could be 3, anything, right? So I can say that x equals to some constant k multiplied by L minus y. Let us look at this equation once again. You know that k is a constant, right? It could be anything, 1, 2, 3. Let us try plugging in some values. What happens if I put my value of k equals to 1? Then I will get x equals to L minus y, right? So what do you see over here? This is the value x and this is the value L minus y, right? So if I place a pointer at the head and if I place a pointer at this position, they will both meet at the beginning position, correct? So if the value of k is 1, this solution will work. Now, what happens if the value of k equals to 2? Nothing to worry about. The value of x will just change to 2l minus y. This simply implies that this value of x will be a little large and your slow pointer will complete one more L length loop and then once again it will reach at the meeting point. Once again it will travel a distance of L minus y and they will ultimately meet at the same starting position. So you can see that this constant k could be any value and every time you start a pointer from the starting position and the meeting point, they will every time meet at the beginning of the loop. Now let us try to see how all of this looks actually in a code. On the left side of your screen, you have the actual code to implement this solution. And on the right, I have a sample linked list that I will pass into the function. So this head gets passed into the function as an input parameter. Next, what do? You start two pointers, slow and fast, that are starting from the head. The slow pointer will move only one node at a time, and the fast pointer will move two nodes at a time, right? So I have two pointers, fast and slow. Next, what you do is you run a while loop and advance both at different speeds until and unless they meet once. So what will happen over here? The fast moves two places and the slow will move only one place. This will keep on happening, right? Ultimately, the fast pointer and the slow pointer will point to the same node, correct? What do you do next? You know that as soon as they meet, start from the head pointer again and advance both the slow pointer and the head pointer at the same speed. So let us do that now. The slow pointer will move one place and the head pointer will move one place. Slow moves one place again, the head moves one place again. As you can see, as the slow pointer moves one step ahead again, the head and slow are pointing at the same node. And this is where you stop. And you just return this slow pointer as your answer. This will be your starting point of the loop. The time complexity of this solution is order of n. That is because we are traversing through the entire list once. And the space complexity of this solution is order of 1. That is because you are not consuming any extra space to determine the solution. I hope I was able to simplify the problem and its solution for you. As per my final thoughts, take a moment to think and realize how we took advantage of power of mathematics and arrived at a solution. That is why understanding number theory is very, very important. Always try to visualize the problem and derive some insights from it. This can lead you to a very efficient solution. What other approaches you came up with and what problems did you face with this method? Can you think up about some other scenarios where the fast pointer moves at a 3x speed than the slow pointer? What happens then? Try to work out a solution. Tell me everything in the comments section below and I would love to discuss all these kind of things with you. You would be also glad to know that a text-based explanation to this content is available on the website studyalgorithms.com, a pretty handy website for your programming needs. You can check the link in the description below. As a reminder, if you found this video helpful, please do consider subscribing to my channel and share this video with your friends. This motivates me to make more and more such videos where I can simplify programming for you. Also let me know what problem do you want me to solve next. Until then, see ya.